Okay, so let's do the same kind of problem, but just a little different, right? So C is a midpoint, and it's at 1, 5. It's ultimately going to be the midpoint of AB. A is over here. It's ultimately going to be the midpoint of BC, and this is B. All right, so remember, these are midpoints, and this is a mid-segment triangle. All right, so let's break it down a little different than last time. Step 1, find slope of any mid-segment, and we're going to say don't reduce. Alright, so let's just do the slope of BC. That looks like it's going to be pretty fun. So the slope of BC is up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oh, we saw that last time, right? So it's a rise. Remember, slope is always rise over run, and it's going to be 4 over 6, and we don't reduce. All right. Now, what am I going to do with this? Step 2 is go to last point. So in this case, it's going to be A, and replicate the slope in both directions. Alright, and why do we do this? It makes equal slopes make it parallel, and then both directions double the length. Alright, so that's why we do it. We want to keep the same slope to make it parallel, and by going in both directions, I'm going to double the length, and that's why I don't reduce. So from A, I'm just going to go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Boom. Alright, and then down 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Boom. Alright. So again, BC and this line right here are parallel, and we'll worry about labeling the vertices later. Alright. And then step 3 is repeat 1 and 2, but with different side, obviously. Alright, so you're going to do the same thing, but we can pick any other side. Let's pick AC. Alright, so I'm going to find the slope of lowercase ac. In this case, it's going to be a negative 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Alright, so down 7 over 3. Alright, nice, negative. Nice, negative. And this is really cool right here, because if I go to B, the opposite point, the last point, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So it's kind of a way of confirming. Notice how I landed at a point I already had. That's good. And then I'm going to go up. 1, 2, 3, 4, 5, 6, 7. And left 3. 1, 2, 3. And then connect. And then step 4 is the hardest of them all. Is connect to make final side. Alright. Sweet. Alright. That's it right there. Alright. And then let's go ahead and do this one last time for some practice. We don't have to write out the slope or the steps. We got them right here. Make sure you at least wrote them out for number 1, because it's going to help you reference them in the future. However, we have these points right here where this is, C, A, and B. Alright, well, I can even just write out the numbers. So I'm going to find a slope of any side I want. I'm just going to do the slope of CA, because I'm allowed to. Alright, so 1, 2, 3, 4, 5, 6, 1, 2, 3. All right, so it's down 6 over 3. And remember, don't reduce. All right, now I'm going to go to any side. All right, I got to go to the last side, so B, and replicate that in both directions. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. All right. So I did steps 1 and 2. We'll just kind of make 2 and write checked. Now I'm going to repeat that for step 3. I just got to pick a different side. Let's do AB because that looks pretty fun. The slope of AB is 1, 2, 3, 4, 5, 1, 2. So from C, I'm going to go up 1, 2, 3, 4, 5, right 2. 1, 2, 3, 4, 5. So I went down 5, now over 2. So it was down, what was it, 5 over 2. And then the fourth and final step, check, just connect the points, and there we go. And remember, I think I forgot to do this in the last one, that'd be A, B, and C, because they're opposite. Lowercase are opposite the uppercase letters. Alright, now we got some logic problems. Suppose you know that the mid-segments of a triangle are all 2 units long. What kind of triangle is it? Well, if all the mid-segments are 2 units long, that means all the opposite sides of the mid-segment, so the opposite sides, which are actually the sides of the triangle, are all 4 units. Well, if they're all 4 units, we'll write all 4 units, that means it's equilateral. Equilateral, equiangular. All right. Suppose if you know that the mid-segments of a triangle are all unequal lengths, what kind of triangle is it? Well, if all the mid-segments are unequal, all opposite sides, so all the sides of the actual triangle, all unequal. So we don't know what kind of triangle this is angle-wise, but we do know it would be scalene. Cool. All right. And now just a little prep work and foreshadowing to circumcenters of a triangle. This is stuff we're going to be doing tomorrow. All right. So it's just kind of a warm-up, a foreshadowing, a cliffhanger, whatever you want to call it. The dotted line of the image on the right is a perpendicular bisector of the green segment. So it's saying that where this point of intersection right here, which is 6, 5, it's saying that that's a midpoint because it bisects, and then it's also perpendicular. All right, so that's a right angle. And while we're here, just it's kind of hard to see. That's 2, 7. That is 10, 3, and that's some random point right there. All right. So recall that the point of intersection for the bisector is a midpoint. Use the midpoint formula to show that 6, 5 is the midpoint of the green segment. So we're just confirming that that is in fact the midpoint. So remember the midpoint formula, we've reviewed this a lot, is you add the x's together. We're struggling a little bit with this stylus. I think this stylus is on its last few notes. It's almost time to retire this stylus. But you just add the y's together, add the x's together. So I already labeled them. Again, for fun, I can say, well, this is x1, y1. Again, it doesn't matter which one's which. It just matters that you stay consistent. Whatever x1 is, y1 has to be in the same thing, so on and so forth. All right, so we get 2 plus 10 over 2. We get 7 plus 3 over 2. And remember, this is an ordered pair, and in fact, 6, 5 checks out good. All right, So midpoints, again, those are very important, and you wouldn't believe how much they use them in like computer, what do you want to call it, like those Disney's movies, how they make characters and stuff like that. We'll actually maybe watch a video if we have time in class. All right. And then, let me think about this one. Recall that perpendicular lines have a slope formula that are opposite reciprocals. Use the slope formula to determine that the slope of the dotted line is perpendicular to the green line. All right, so let's just go ahead and find the slope of the green line first. And again, remember, this is the slope formula. Subtract the y's over subtracting the x's. All right, so I'm going to get 3 minus 7 over 10 minus 2, which gives me negative 4 over 8, or negative 1/2. All right, so that's the slope of the green line. The slope of the dotted line, I'm going to help you guys out a little bit. Let's use this point and this point, and we can clearly just count 1 over 2 is 2. All right, opposite reciprocals. Remember, we changed signs. And we flipped, so it checks out. So just a little warm up tomorrow. We'll be using perpendicular bisectors, just confirm some things.